Hi, now we are continuing our lecture in Simple Linear Regression or SLRM Part 2. Right? In this video or lecture video, I will continue our lecture on hypothesis testing, where after watch the Part 1 YouTube video of SLRM, in this video, we will do the hypothesis testing for the magnitude calculated in video SLRM Part 1. But before we proceed to the hypothesis, we have to calculate in manually the standard error for beta 1. The following formula is important in order to calculate standard error for beta 1. This calculation also important for your final assessment. Standard error formula for beta 1. This is actually step 4 from the beginning in our lecture part 1. So this is step 5, where for step 5 we have more than 6 formula you have to remember. The first formula is SXX. This is the formula for SYY and also for SXY. This formula is very important in order to calculate for the standard error for beta 1. The summation value here, actually we already get from the table in lecture part 1. This is formula for number 4, 5, 6, and 7. Then we have some example to discuss. The student can refer to page 38 until 40 as a calculation example. Also some other example in page 133. These all examples are in your econometric module. Further discussion, recall an example from lecture week 3. This table, we already discussed about this table. We have to calculate every time when you get this table for simple linear regression model, you have to calculate and you have to sum up all the numbers here. Right? And we also have the mean value for yi bar and xi bar. Calculation for standard error for beta 1. XXS after calculate is become 1016. SYY after calculation we get 399.6, and XXY we get 6 to 1. And we continue the calculation finally until at the end we get the value for standard error of beta 1, which is this one, and the value is actually 0.04669. So what are we going to do with this number? Next slide will show you what we're going to do with this number. Standard error value for beta 1. Therefore, the standard error value for beta 1 is SE beta 1 0.04669. This value will be used in the hypothesis testing. The hypothesis testing has 4-step procedures, which is the first step is hypothesis, the second step is statistical test, the third step is critical value, and the fourth step is calculation and graph of t-distribution. Okay, let's go and start with step 1, that is hypothesis. Step 1, graph the hypothesis. The hypothesis will be hypothesis 0 here is hypothesis null. Hypothesis null is beta 1 equal to 0. And alternative hypothesis is H1 is beta 1 not equal to 0. Step 2, statistical test. Recall value for beta 1 equal to 0.6112 and value for beta 0 is 0.0208. Step 2 is statistical test, where we have to calculate by using this formula, and beta 1 is actually we already calculate in part 1 video of simple linear regression model last week. So we have to calculate this one. Beta 1 is 0 because in the hypothesis say that beta 1 equal to 0. So SE beta will be used in here. So just substitute the number into the formula. We finally get the value for statistical test, which is represented by T star, is 13.090. Step 3. Critical value at 5%. I will provide further video to explain how to use the critical tab to get the critical table value by using the statistical table. In this stage, the value for critical value at 5% is 2.776. Step 4. Conclusion and graph. This is actually the graph of T distribution, where here in the yellow box is the critical value, where the critical value will divide in two zones, right tail and left tail. Therefore, it will take the negative value and the positive value. At the middle zone here is the accept HO zone, and out of the middle zone, this side and this side is the reject HO zone. According to our value of critical value is 2.776, which is going to take negative number and positive number in the left and the right zone. However, according to statistical test value, the value is located somewhere here, which is 13.090 is larger than 2.776. So we have some idea that the statistical test value is somewhere around reject HO zone. Now let's go to the next slide. Final conclusion for hypothesis test. According to the result of hypothesis test, we found that the value of critical statistical value is larger than the critical value, where 13.060 is larger than 2.776. So we have to reject HO, or in other words, reject the hypothesis none. In other words, the income is important or significant in explaining or in influencing the money spending at 95% significant level. This finding is supported by the T distribution graph. Do you still remember in our previous lecture that actually the case is we want to see the relationship between income and spending pattern. So until that, we are going to use that example. So by using the hypothesis testing, it's proof that the income level is important in explaining the spending. The income is important in influencing the spending pattern. So in the next lecture, we will do or we will have another example maybe. So that's all for now. You can refer to the many examples in the econometric module to have further calculation example, and also to do some example, to do some tutorial as well, to make sure that you really understand of how to use this formula in correct way. Okay, thank you.